Hi there. We are still on the review portion for triangle similarity, and we are still on the two-column proof concerns. Aside from the presentation of a two-column proof, we also need to understand or re-understand, revisit triangle congruence, because when proving theorems in triangle similarity, we need to first pass congruence of triangles. Now, we could only determine that where the two triangles are congruent if the corresponding angles, corresponding sides of two triangles are also congruent. This is very easy. This video will just be very short because this is just on identification on which parts are corresponding or not. This may seem easy, but if you're not uh, going to practice identifying the corresponding parts, it will be very difficult for you to understand similarity, corresponding sides, corresponding angles of triangle similarity later on. So here in this practice exercise, again, this may be short. Okay, we are asked to determine if we are determine we are going to determine first the correct notation for congruence, and after which we need to give the relationship between corresponding parts. Okay, so to do that, let's examine here the two triangles here. They are not placed in the same way, okay, but you may just look at the notations used here. The notation used for side are slashes. Those with the same number of slashes are actually the corresponding sides. 3, 3, 2, 2, 1, 1. For angles, we also used here the number of arcs used. So the same number of arcs used per angle determines the number or the same, the corresponding angles. Okay, but then again, some of us are not really that um, comfortable when we're looking at the figure. So what we could do here is this. Let me copy this one here. Okay. For those who have problems in identifying uh, corresponding sides, I may ask you to rotate this, okay, and in such a way that it could probably look like the given. It's more or less until earlier. Okay, sorry for that. Mhm. So more or less, it will actually, because there are no in this area for paint, there are no other degrees of rotating. So probably let's just be okay with this, or you could rotate it better in your own area there, so that we could come up with the corresponding sides. Take a note that when we move this a little bit further or rotate this a little bit further clockwise, and you might notice that the corresponding number of arcs will be the same here, two here, one, and then number of um, slashes for sides. So to come up with our correct notation for congruence, take note that the notation for congruence is actually this symbol here, okay? The equal sign with a tilde here. So we could come up with the correct congruence between two triangles. Let's use F, G, and use here triangle. Triangle FGH is congruent to not necessarily RST, same as the given here. You might be confused with that FGH, RST. It is actually using the corresponding sides. It would be S, starting with the angle with the three arcs, and one and then two. So you have triangle STR. This is the correct notation for congruence. And out from this, if you could already come up with this notation, you don't actually need to return and looking the given figures that may confuse you um, more. You may use this to come up with your relationships of sides and parts and angles rather. So you'll have angle F is congruent to angle the first vertex here, first vertex on the other side. So you have angle G, the second vertex is congruent to the second vertex on the other side, C, and the last H is congruent to angle R, right? Okay. And finally, for sides, you may just simply use the pattern here. Side or segment FG is congruent to segment or side ST. Right? You may actually use TS here, right? Because again, segments when the endpoints are interchanged are just the same. But let's just use ST so that we will not be confused anymore. And then you have F and H. Segment FH is congruent to segment SR. And finally, GH is congruent to segment TR. Okay. The reason why I also included this as part of the review, the determining of the corresponding parts, aside from helping us later on with our triangle similarity and congruence, is that you need to learn how to um, use the notations properly. Take note that if we talk about parts like angle F, angle G, angle H, S, T, R, and even the sides F, G, F, H, G, H, S, T, S, R, and T, R, we use the term congruence. We all know that congruence means same measurement, but we cannot use here angle F is equal to angle S. Okay? Because if we talk about parts, we always use congruence. Okay? So for equality, we will use measurement. So we could also rewrite this. We could say the measurement of angle F is now equal to the measurement of angle S. So if we talk about equality of measurements, not equality of parts, we could only say congruence of parts and equality of measurements, not the equality of parts nor congruence of measurements. Okay, so you have here measurement of G is equal to, do not use congruent, measurement of angle T, measurement of angle H is equal to the measurement of angle R. You need to know this properly because when you try to come up with your proof as well, it will be incorrect if you will use congruence here nor equal here. It should be in the correct notations. And for the sides, other references before uses measurement of FG. Right. Okay, but let's just simply use side FG is equal to ST. That means it already indicates the measurement of FG and ST. Okay, so without the bar, because if you have here bars here, that means congruence because bars means parts, but here measurements. FH is equal to SR and GH is equal to TR. Again, this is not part of the unknown here or the request for the spread exercise, but I'm just emphasizing the proper use of notations. If we say parts, we use congruence. If we say measurements, we use equality. Okay? So please review this understanding as we go further and dig deeper on the triangle congruence and probably later on triangle similarity. Thank you very much. See you soon.